Hello everyone and welcome to this tutorial. Today we're going to learn how Docker works from the perspective of a JavaScript developer like myself who is interested in learning more about what Docker does and what problems that it solves. So we're going to create a Node app, a little web server. We're going to create a front end for it, and we're going to create a connection with the database for it. And we're going to use Docker as an example to create kind of a scenario that you might run into with a job where the version of a program that your project requires doesn't necessarily match up with the version that you have on your machine, or you don't have that program on your machine at all, or you don't necessarily want to install it. You don't want to get every team member to install it, et cetera, et cetera, et cetera. If you could just basically have a set of instructions that automates the installation of the exact version of the exact program that you need every time you're running your development environment, that's exactly what you want, and that's exactly what Docker can do. So we're going to use that as kind of the first example for what we're doing. And the other thing that we're going to do is we're going to use it to simulate when you want to connect to another service that your app requires in order to work. So what might most commonly be used in a scenario like that is you have a backend, like a Node application that needs to connect to a database. So your database might exist on another server somewhere, you connect to it, but if you want to be able to test it locally, then we can create a separate Docker container that runs the database and another one that runs our backend, and we can connect them both together with a tool called Docker Compose, which is really, really cool. And we're going to learn how to use all those things by creating a little app from scratch. And by the time that we're done, we'll have a full stack Node app that connects to a Postgres database and queries for some data and displays it on the screen. So stay tuned and we'll get it working. So we have absolutely nothing right now, and that's exactly what we want. So I'm here just in a home directory of my machine. I'm going to make a directory called, let's say, Docker, let's call it Docker Template. Okay. And now I'm going to open up a new VS Code instance, and I'm going to open up that folder right there. So bear with me for a second here. And where's my home directory? Docker template, select it, and here we are. So this is the Docker template folder that I just created. Open up a terminal in VS Code, and we are ready to go. I'm going to start by creating a little Node backend server. So I'm going to initialize an npm project with npm, if I actually click there, npm init with all the defaults. Boom, everything's okay. And I'm going to use an express server to make it really simple. So I'm going to do npm install express. Okay, great. Normally I use TypeScript, but it's actually not, doesn't add too much to this tutorial. So it's one of the rare occasions when I'm not going to use it, just because I want to focus on the Docker learnings in this one. Okay, I'm going to create a new file called server.js, touch server.js, or you can just say add new file over here, one or the other. And I'm going to just copy this little example that I've already created. So we're requiring Express that we installed already. App equals Express. We're going to run it on port 8080. Whenever we get a GET request to the root route, we're going to send back some HTML. Everything's okay, 200 status code, and our HTML is going to be H1 that just says hello world. And our app listens on port 8080. So I'm going to save this, and I'm just going to make sure that it works. I'm going to run node server server.js, hit enter. It says that my app is listening on port 8080. Let's double check and make sure. Localhost 8080. Doesn't work. Why doesn't it work? It says it's listening on 8080. Why doesn't it work? I mean, this is like pretty straightforward stuff. So now I'm going to run the little server that I made, server.js, hosted on port 8080. Open up my browser, and I go to localhost 8080, and I should see my little hello world. Hey, there it is. Whoa! Excellent. Well, that's good so far. Let's get that out of the way for now. So, we've got a little backend server that sends some HTML data. That's great. What should we do next? So the other thing that we want to do is we want to be able to, while we're running this, we want to be able to make edits to it and save it and get updates in our browser. So right now we don't have that set up. So if I change what's being served here, hello world, and I refresh, I'm not going to get a change. So I'm going to quickly install a little tool that allows me to do that. The tool is called Nodemon, however you pronounce it. npm install Nodemon, and that's a development dependency. I only need it for while I'm developing. Save dev. Okay, so that's installed. So rather than running node server.js, I'm going to create a little script in my package JSON file. Don't need this test one because I'm not working with tests right now. I'm going to call it start. And for start, what we're going to do is we're going to do nodemon server.js. So the only difference here is rather than regular node, which won't restart when I edit server.js, nodemon will watch server.js for changes and restart it automatically whenever I edit the file. So if I do npm run my new script, start, and enter, it's listening on 8080. Let's go back here, refresh, but if I move that out of the way for a second, go to server.js and I say just hello world 1 2 3, save. As soon as I save, you're going to see this update here. Save. Oh, something happened. Bring back my browser and I hit the refresh button. There we go. So we got some live reloading with the refresh button. So that's going to come in handy later, and you'll see how it does. So here's where Docker starts to come into play. So let's imagine, as simple as this little app is that just says hello world, let's imagine that this is a big company app that has all kinds of legacy code and all kinds of yada yada yada, lots of problems, lots of things that you need to fix, and for one reason or another it just doesn't work on the new versions of Node. I think Node 17 just came out fairly recently, but not the project that we work with our company. It only works on versions of Node that are older than version 15. And the reason that I say that is because version 15 introduced a breaking change, which means that it's a type of code where apps that used to work on versions earlier than Node might not necessarily work on the newer versions. And that's exactly what we're going to kind of pretend that we have here. So I'm going to copy a little tiny blob of code that I created and sort of explain how it works. So what this is going to do, it's going to add something to our server. My promise creates a new promise, resolves and rejects, and it's going to reject every single time. And I did that on purpose. So it has a timeout, a 300 millisecond timeout where the promise resolves, but long before the 300 millisecond timeout happens, we're going to reject it. And we're going to say, nope, that's bad. And then we're going to say, oh, my promise then, which will run the resolve path, if you're familiar with promises, and it'll do this. But this is never going to run because we already know that every single time this new promise happens, it always rejects. So what happened before Node version 15, rejected promises were, you got a little warning saying, oh, this isn't very good. Be careful for it. But from Node version 15 and after, promises that were rejected that weren't handled with a .catch block, if you didn't catch it, then it actually crashes your entire program. So what I'm going to do is I'm going to save this, okay? And I'm going to say, let's look at what Node version I have installed on my computer. Node version. So I have 16. So I have a fairly new version, I guess second newest version there is at the moment. So because I'm running a new version, I should get an error and an app crash whenever a promise is rejected. So let's give it a try. npm run start. App crashed. Why did it crash? Unhandled rejection. Okay, because I didn't handle the rejection of this promise. But like I said, that only started being enforced strictly on Node version 15. So we're gonna show how to deal with this with Docker, but just to show an example, there's a tool called NVM, Node Version Manager, that lets you quickly change your node version. So I'm going to do NVM use 12, version 12, which is an older version. So now when I say node version, I'm on version 12. So this is an older one, which didn't crash your program when promises were rejected. So let's see what happens if I do npm run start. My app is listening, 8080, and I go here, refresh, it works. So it works on node 12, but it doesn't work on node 16. So that's great for me. I'm using npm. I can switch back and forth between them. But what if I have, what if we're working on this app with, a lot of different developers? What if we're managing, multiple different projects? Some of them do work fine on Node 16, but this one that we're working with only works on older versions of Node. Do I have to remember to switch back to version 12 every time I want to run it? Does the 3 or 4 or 10 other people that I work with have to remember to do that? Isn't there an easier way that we can, automate this? Basically create an instruction that says, hey, if I'm running this application, if I want it to work properly, I need to clarify that I'm running it in an environment that has at least a certain version, a specific version of Node that I know that this application works in. So that's one, there's many things that Docker can do, but that's one example of something that Docker is really, really good at. You create what's called a Docker file and you write instructions on exactly what version of all the software that's required in order to run your application. So with that said, let's pretend that I don't have NVM so readily available to me. I'm going to go back to 16, which I like quite a bit, but start my app. Doesn't work. What can I do? Let's introduce Docker into the mix here. So the thing about Docker is that you want to make sure that you have it properly installed with whatever operating your system you use. And there's a lot of, the way that you install it is different for each operating system. I'm using Windows 11 right now with something called WSL2, Windows Subsystem for Linux. So technically I'm running Ubuntu version 20, even though I'm on Windows 11. So this would be the equivalent process if you were running Ubuntu. It's going to be different for Mac, and it's going to be different if you're running just straight Windows using PowerShell. So you'll need to figure out kind of on your own exactly how to install Docker on your machine. But once you have it installed, then this video will explain kind of how to implement it with your web apps. So I'm going to open my start menu. I'm going to run down and I'm going to open up a program called Docker Desktop. And this is going to give me a nice little GUI for Docker. It's not required. Most of what we do, we're going to do on the command line, but this is going to get it at least booted up. So when I say Docker version. Still booting everything there. Docker version 20. So as long as you got a Docker version when you run Docker version, then you are ready to go. Regardless of what operating system you use, if you can access Docker from the command line, you are good to go. So what are we going to do next? We're going to add a Docker file that will describe exactly the environment that we need in order to run this app properly. So I'm going to create a new file called Docker file, literally just Docker file, no extension. Touch Docker file, enter. Oh, there it is, and it's empty. So what do? I'm going to copy from my own tutorial, makes it really easy, paste it, and I'll kind of explain each piece of it as we go. So this is the base image that you're starting from. So you'll go, I'm not going to go there right now, but if you go there on your own time, go to a site called Docker Hub. That's where the vast majority of Docker images are stored, and that's where this is going to pull from by default. It's going to pull from the official Node.js image, and then after the colon is which version or which tag, they call it, are we going to pull from. So we're going to get Node version 14, and it's going to be running on Alpine Linux. And if you're not familiar with Alpine Linux, Alpine is just a really, really small, lightweight version of Linux that has barely anything installed. And that's great because it means that, we can run lots of different Docker containers on our machine, and each one of them is only going to be, a few megabytes, as opposed to if we were going to run a full container that has a full installation of something like Debian or Ubuntu, which might be, to be honest, I don't know off the top of my head, but maybe a few hundred megabytes or something like that. But Alpine is just about as small as it can get, just enough to be able to run whatever program you're running, and not much more than that. So next, we're going to describe which directory we want to, within the Alpine Linux environment, what directory do we want to run our app in? We're going to run it in the user source app directory. And next, we're going to copy our package JSON files. So this little asterisk is a pattern. We're going to get package JSON, and we're also going to get package lock JSON. And the nice thing about this is that it's specifically just going to copy those two files. And when it does this, it's going to cache the result of that copy. And as long as package JSON and package lock JSON don't change, then you don't have to rerun this step in the layer that Docker is creating as it's going through these things one by one. And if that doesn't make sense now, that's no big deal. You'll kind of understand it a little bit better as we go on. So after it copies your package JSON file, it's going to run npm install. And because npm install installs all the packages from your package JSON file, the result of this is only ever going to change when this file changes. So as long as this file doesn't change, the result of npm install doesn't change. And that's important because npm install is one of the longest processes when it comes to building, a brand new app from scratch. If you clone a repository and you're like, oh, I want to run this project, you run npm install. It might take, depending on your machine and your internet speed, it could take anywhere from a few seconds to a few minutes. So this is one of the longest steps in the process. So what you're saying here is, after you've copied package JSON, as long as this doesn't change, then you create a cache, a layer in Docker where this process will not need to be run again unless you update these files. And that's one of the big efficiencies that Docker gives you. So after that, we copy the rest of this whole directory into our container, copy current working directory to the containers working directory, which we've described as user source app. And that's going to happen on every time that you build this image. But again, not to sound like a broken record, as long as we don't change these specific files, we won't have to run npm install every single time. Next, we're going to expose port 8080. And the reason we're exposing port 8080 is because our little server runs on port 8080. So we need to be able to access the container on that port. So that is the only port that we're exposing to our outside environment to be able to access. And lastly, what command starts our application? So rather than doing a simple npm run start, the way the Docker works is you do cmd for command, and you do all of the arguments individually in an array. npm run start, and that's going to run the start script in our package JSON file. Great. So so this has the full instructions on exactly what is needed for our app to work. It describes that Node version 14 is required for our app to actually run. So if I run npm run start on my own machine, crash, doesn't work because of the promise resolve, doesn't work on my Node version 16. But I have this Docker file which describes, hey, the working environment for my app is Node version 14 and all of these other considerations. So what do I do now? I simply do docker build, sorry, gotta remind myself, current directory, and give it a tag name, and I'm going to call it my node app. And I'm going to hit enter, and it's going to build based on the Docker file. It's going to build an image that has my app running in it with all of these instructions, including Node 14. Now it was very quick because I've already run this before, so I didn't have to download that. But if your machine didn't have a copy of Alpine Linux and Node 14, this process would take a little bit longer the first time you run it, because it would actually automatically download those from Docker Hub for you. Oops, didn't save it. Let's do that again and make sure it worked properly. Save, Docker build. That's a little better. Okay, it's running npm install. Ooh, it failed. Why did it fail? It failed because I ran curl. I was using this as an example earlier. We don't need that. Alpine Linux doesn't have curl installed. I'm gonna delete that. See? So you can run, you can use it's a good example though. You can use the run command to run any, terminal Linux command that's available to you. So what I was doing earlier was I was showing an example of how you could run curl with google.com. If you're using, a large image like a Debian image, curl obviously is going to be available to you. It's a standard package, but with Alpine, curl isn't installed. So you actually have to run apk, add curl, and then google.com. So if I was to build this image, I got an error before saying curl didn't exist. But with your Docker file, you can actually use your package manager inside that environment to install it first. See? Add curl, and then running curl works properly. Doesn't do anything, but it's a good example of something that you can do with your Docker file. You can, if the image that you're using is missing, say, a program that you want or wants to do something, you don't have to necessarily go and find a different image. You can simply add an instruction in your Docker file to install a program, and then as soon as you're done the run instruction, you can use it. So now that the Docker image is built, what do we do? Well, we can run that image as a container with a command. It's going to look like this. Docker, copy, Docker run. What port do you want to run? So we're going to run port 3000 on my machine, and it's going to map to port 8080 in the container. And if you remember, port 8080 is running our Node app. I'm going to give it a name, my Node app container, to differentiate it from the image that we're basing our container off of, which is called my Node app. And that's what we built with the previous command. The previous command built an image called my Node app, and we're taking that image and using it to create an actual container which is running the app. So if that's a little bit confusing, that's okay. The image is like the instructions, the blueprints, the documents that are ready to go that said, here's how you make the container. And then the container itself is like the actual product, the house that you built from the blueprints, the thing that the thing that exists, the thing you can actually access and run your app inside. So that's what we're doing now. Docker run my Node app container based on the Node app image instructions on how to build it. So I hit enter. And good, I don't, I get a couple of warnings about unhandled promise rejections, but you notice I don't get an error because my Docker file says I want to run this on Node version 14. And when I ran it, I'm mapping port 3000 on my computer to port 8080 on the container. You can map port 8080 on your computer to 8080 on the container, and that would work fine as well. I'm just showing this as an example of how you can map different ports on your machine to the ports that run on your container if you want to. So I need to go to port 3000 to access port 8080 on the container. So if I open up my browser here, go over, and I go to local host 3000. Oh, that's 300. That's not going to work. 3000. Oh, hello world. Right here. This is my app. But here's the thing. Okay, hello world. It's great. So if I edit this server.js file on my computer, is it going to update the app that's running here? Let's find out. Let's get rid of all these exclamation points. Save. It's saved. I'm going to refresh. Doesn't work, or doesn't show the changes. So why doesn't it show the changes? So it doesn't show the changes because we're not running server.js file from our machine. We're running it from inside the container. So the container is a whole virtual environment, just like my machine, but one that copies all the files from here and runs it in a totally separate environment that follows all the instructions that we wrote in the Docker file, one that runs Node version 14, and it runs Alpine Linux 3.12. So changing files on my machine isn't going to change what's running in the container. So it might be a little bit inconvenient at the moment for what I'm doing, but it's a good thing. It's a positive thing because it means that I can take this Docker file and I can send it to all of my coworkers or anyone else and say, hey, do you want to run my app? And all they have to do is say, Docker build and Docker run, and they're running the app as well. It doesn't matter what version of Node they have installed on the computer. In fact, they don't even need Node installed on their computer. The only thing that they need installed is Docker to get this working. But that said, it would be nice if we could edit this file and update, and work on it while use Docker, but still be able to make changes to our backend and have it update in the browser while we're working on it. So let's see what we can do about that. So to fix that issue, we're going to introduce something called Docker volumes. So I'm going to close this down. Docker volumes is basically synchronized folders from your machine on the container. So what I want to do is synchronize this project directory with the user/source/app directory on the container. So they basically, have a link that treats them as exactly the same directory. Changes I make here will be reflected in the container. Changes I make in the container are going to be reflected here. So let's see what I can do for that. So to do that, what I need to do is first I'm going to remove the container that I just built, Docker container. Let's take a look at what there is. I'm going to say list Docker container ls. Oh, doesn't even show it there, so that's good. Because I control C and I stopped it already. So I'm going to remove that container, Docker container rm. Oh, my node container. So this gets rid of it because I want to recreate it again, but this time with a volume mapping from this directory to the directory inside the container. So what I'm going to do is the same command that I ran last time. Here, see, Docker run 3080, my node container node app, but with an extra flag that defines a volume. So that's a highlighter here, right there. So same command, but create a volume, pwd, which stands for print working directory, which means the current directory that I'm in right now, to my Node app. And let's run that. So it's running now. So what that's doing is it's the same app, the same container that I ran before, but it creates a volume being a persistent directory from my actual machine to the container. Current directory. You could give it you can give this a name if you want, and what it does is it saves it in Docker's wherever Docker's installed. It has a directory for named volumes. So if you want to call it my custom directory, you could use that name instead of pwd and map it to this, and it would save whatever the contents of this folder in your container to Docker's custom volume directory. So you would still have persistent data, it just wouldn't be mapped exactly to the data that you're working with in your project. So what should happen now is I have my server up and running. Once again, port 3000, hello world. So last time I edited the file on my own machine, it didn't update this. Let's see what happens now. So move it out of the way. Server, hello world. ... 1, 2, 3. I'm going to save. So I edited the file on my machine, nothing to do with the container, but because I created a volume that mapped the working directory that I'm in to the source directory of the files on the container. If I refresh localhost 3000 on the container, I see that the change that I made on my machine was reflected inside of the container. So that gives me a mapping of the volume on my machine to inside the container. And that's really handy to be able to do. Docker volumes are really cool. So what's next? So next, we are going to connect a database to our back end. So the reason that we do this example is because we want to show what it's like. Pardon me. We want to show what it's like to simulate kind of a real app deployment. So if you wrote a backend in Node, for example, you might deploy that to wherever it is, DigitalOcean or Vercel or Netlify, wherever. But it's not likely that the database that stores the data for your app is going to be deployed in the same location. So if I were to install, if I were to update my Docker file and say add a database or install a database or anything like that, it wouldn't really represent the environment where I'm deploying this app. So we want to have our local development environment emulate our production environment as closely as possible. So it would be nice if we could have the database locally, but make it an entirely separate entity that we can communicate with our app. And we can do that using a tool called Docker Compose, which will take multiple containers and essentially run them at the same time and create a network that allows them to communicate with each other really easily. So that's what we're going to do next. So the first thing that we're going to do is we're going to decide what database we're going to use. And we're going to use Postgres for that because Postgres is really cool, really easy to use, and there's rarely any scenario where it isn't simple enough or powerful enough to do whatever it is that you want to do with your app. There's an easy to use Postgres image on Docker Hub. There's images for all the popular databases on there as well. There's MySQL, MariaDB, Redis, Mongo, blah, 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 all of them. If you want to continue and try this tutorial with one of the other ones, that's any single one of them would work just as well as the other. I'm just choosing Postgres because I think it's great and always gets the job done. So before we connect the database, we want to update our server to use the database. So what I'm going to do is I'm going to go back to my server.js file. I'm going to close, Control C here, and just stop this Docker container for the time being. And I'm going to add the Postgres client for Node so that we can use Node to query our backend database. We haven't created it yet. We're going to write the code first, and then we'll connect the database. So I'm going to do npm install pg. That's Postgres. If you look it up on npm pg, that's the Postgres client. So once it's installed, all I have to do is add. Again, I'm going to copy what I've pre-written here, but I'll explain how it all works. Most of this is just what I already have with a few extra things. So I'm going to import Postgres, client from Postgres. This is all the same as it was before. I'm going to connect to the client, password root, user root, host Postgres, and you'll see where these values come from when we create our Docker compose file. So these don't mean anything yet, but they will very soon. We're also going to we're also going to serve a static directory using Express. So rather than just returning an HTML string, h1 that says hello world, we're actually going to serve a folder that we'll call public, and we'll put a real index.html file in there, and that'll let us also put a JavaScript file and some CSS to create a front end that looks a little bit better. We're going to create a route called employees. So whenever someone sends a GET request to employees, it's going to query our client. It's going to select everything from employees, again, which we haven't made yet. Then once it's done the query, it's going to take the payload .rows, so all the rows that this SQL query returns. If we get an error, we'll throw an error. And it's going to return those rows as results. Once those results are back, we'll get it as an array, which we can send to the front end as JSON. So set the header as content type, application JSON, 200 positive, everything's good status code, and we'll stringify our JSON for the HTTP response, and we will send those rows to the front end. Next, we want to make sure we connect to the database before we start listening with our app. So we're going to run a little IIFE, integrated something functional expression. I forget what it stands for, but basically immediately invoked function expression. That's what I remember. So we can't do a top level await, but as long as we create a function that we invoke right away after creating it, it'll simulate the same thing as waiting for the database to connect, and then have our app start to listen. And the last little bit is still that stupid little promise that we wrote to break our app on purpose so that it only works in versions of Node that are older than version 15. So once again, I save. Once again, if I run npm run start, it crashes because this app does not work on my machine. I have to have a Docker setup that creates the environment for this app to run properly, and that's okay. So what I'm going to do now is I'm going to create this public directory with our front end so that once we get the employees, we can send them to the user and make them look nice. So quickly, new folder, public, oh my goodness, lick, and one of my favorite things about VS Code, create an index.html file, type the exclamation point, and you just get this complete little template already built out for you, which is great. Speaking of templates, I'm going to use the Html5 template element to create the template of a card, like an employee with a name and a title that we can show. All of this code you can get, you don't have to read the video and write it all down. You can get it from the video description. There's a link to a blog post that you can copy and paste it from. So I'll save that. I'm going to create a file called styles.css, and that's just going to be the styles for this card class and container class to make it look nice. Again, I'm not going to go through exactly what all the CSS does because this is not a tutorial about CSS, it's about Docker. So there it is, some nice styles for our body, card, and a little bit of a hover to give it an effect. Format it. You can copy this again from the blog post in the description. And lastly, I'm going to call script.js. And in our script.js, I'm going to use the browser's fetch function to fetch the data from the employees route. And as you remember, on our server, employees returns the result, the rows from select star from employees, and gets the data as JSON. For each employee that it returns, each row, it's going to copy that card template that we have in our index.html, this one here. It's going to clone it, and then it's going to set the text of the h4 as the employee name, and the text of the p tag as the employee title, and then it's going to append that card to the document body. And that's great. So the only thing I think we're missing is loading this script.js and style.js in our index.html. So I actually should have got too excited with that little shorthand in VS Code, but what I need to do is copy my actual template from my example there, which has the script.js and style CSS, and still has that card template. Okay, so that's great. Now we are ready to roll. So we have a front end here, we have a back end here that serves that front end, and it queries data from our database that we haven't established yet. So what is the final missing piece on all of this? If I was to run my server right now, even if I didn't have this, silly promise rejection, I would get an error saying, what the heck is this? I can't connect to a database that doesn't exist. What is this host Postgres? What does that mean? So we haven't defined that yet. The last stage is to define what that means. So we already have a container that runs our backend. We need a container that runs our database, and we need a system that connects them both together, and that's where Docker Compose comes into play. So we're going to create a file in our root directory called docker compose.yml. And I'm going to copy from my example, and we'll take a look at how it works. So it's a YML file. If you're familiar, you should look. It's pretty simple. Tabbed keys with followed by a colon. So our first compose, our first service, each service is a separate container, is app, and this is our backend. This is the same thing that we were already running with our Docker file. So when we say build the current directory, it's going to look and it's going to find the Docker file, and it's going to build the instructions that we already wrote. Depends on means what order should these containers build. So our backend doesn't do anything until the database is up and running. So if someone's querying our backend to get the employees, it's pretty useless if the database isn't going. So when we say depends on Postgres, it means we need to make sure that this one runs first. We map port 8080 to port 8080. Similar to before, I had 3000, but now we're just going to run port 80 on my machine is the same as port 80 on the container. And the volumes. So the syntax for this is a little bit different. Previously we did pwd, working directory, but now we're going to say just current directory with the standard // when we're working with Docker Compose files. And that maps our current directory to the user source app directory inside of our container so that our files will still be synchronized. Secondly, our database. So we're going to pull the Postgres image from Docker Hub, and for that we're also going to use the Alpine version to keep it nice and small. The name of this is really important. So this here, Postgres, the name of that service, look at our server. When we say the host is Postgres, when we're running Docker Compose or we're running these containers, it's going to automatically map this exact name to the IP of the Postgres container. So this here has to match up with this here. The same way that when you type localhost, it automatically maps to 127.0.0.1. Similar concept happening in this. So maps Postgres to the IP of whatever this container is, and that could be different every time that it loads. So you just need to make sure that the name is the same. Restart it automatically, straightforward. You can set environment variables with the environment value. So we're going to do Postgres user is root, password is root, and DB is root. And these are built-in values for the Postgres database. So it's going to create the database, and these values are going to automatically be set with root. And if you need to change these, you can. We're just using those as an example. 5432 is the port that Postgres communicates on, so we need to expose this one so that our Node app can communicate with it. And lastly, for volumes, what we want to do is we actually want to create a seed file that will populate the database automatically whenever it's booted up, so that we have some data to query. And I forgot to do that, but we can do that now. So what it's going to do is it's going to take a file called databaseseed.sql from our current directory, and it's going to put it here, Docker entry point initdb, and that's somewhere that automatically our Postgres image will check and run before the database boots up. So that's where you can put seeded data in order to have data that's already created and ready to go when you start your database. So that step that I forgot, I'm going to create a file here called databaseseed.sql, and I'm going to copy from here. I'm going to paste, create an employee table, and then ID, serial, just increments by 1 every time. Name is text, title is text, and the primary key is ID. So the ID has to be unique. And I'm going to create 3 random employees with names that I got from random name generator on Google, and some nice titles for them, some imaginary job for them, and that's it. So this is Postgres SQL syntax that will automatically create some data, and this file will be loaded when our container is loaded because of this line right here. And I hope that's it. Let's give it a try. So when you're using Docker Compose, which has all the definitions and everything that you need to do, all you have to do is type Docker Compose up. That's it. I like to do that's all you need to type right there. That's it. I like to do a build, and this will force it to rebuild the containers each time you run it. You don't need to do this. It's faster if you know your containers are already good to go and you haven't changed them. But just for the sake of, oh, oops, I forgot I changed something, I should rebuild my containers. I like to do this by default unless I'm working with something that hasn't been updated. I'm gonna hit OK. Top level object must be a mapping. See, I got an error and I don't know why. Save auto format. Could that be it? Does that fix it? No, that actually fixed it. All right, I apologize. I don't know exactly what that was, but I ran Shift Alt F VS Code's auto format for YML files, and it fixed it right away. So now the app is listening on port 8080. Let's, after all these pieces and everything put together, let's see what we got. Open up a browser, go to localhost 80, and look at this. Whoa, whoa. So pretty simple 3 little cards, nothing fancy, but when you think about it, we've got 2 Docker containers. One is running our backend, one is running a separate Postgres database. They are both connected to one another, running on the local machine, running an older version of Node to make sure that it works properly on this on this computer, and it's all being served through port 8080 to the front end, and it's all communicating properly. Simple as that. So if I could do, put another terminal here, close this, I'm going to do docker compose down, and it's going to shut all those containers down that's running. Don't want to shut down, Control C. There we go. So if I go into my database seed and I were to add, A, B, C, D person, and they are the president of Earth, let's say. And then I'm gonna compose up again and rebuild. So all I did was edit the data in my SQL table, but detected the change in that file, so it's rebuilding, not using the cache. App is listening on 8080. Open this browser. I'm gonna hit refresh, and look at that. That's really cool. I think that's awesome. That's pretty much the end of the video. That's Docker Compose. I can do a whole lot more than that, but when it comes to just learning the basics and getting familiar with it, that's a huge win right there, just to be able to get those things going. So I'm going to leave it there. Definitely check out the blog post that this video is based on. I did one more little extra thing where I added the PG admin panel. So if you want to be able to go into adds a third container, so you can check the administration panel for Postgres and run SQL queries against your data and all that kind of cool stuff. That's in there as well with the blog post, so definitely check it out. If you have any questions, leave them on this video. I'm happy to answer them, but I really hope you learned something, because I really like this tutorial in particular. I think Docker is a really awesome tool, and I always enjoy working with it, and the things that you can do to help simplify your workflow are amazing. I remember when I started just even only a few years ago working, I had to got hired and started working with WAMP and MAMP and XAMPP, and I barely even remember them at this point, but I was the sole Windows user on a sea of Mac developers, and it took me I think in almost 2 days basically just to get the environment up and running to work on some WordPress project, and I didn't know any better. I just did what I was told. But I imagine that same scenario right now of just getting it up and running on Docker and just sending it to someone, say, hey, or clone this and type Docker compose up and hit enter, and you go from 2 days worth of configuring your computer and setting everything up to 45 seconds, and you're ready to start working. So it's a fantastic tool, and I hope you enjoyed this video, and I hope you learned something. So thanks for watching, and have a great day.